In this video, I'm going to go over 2024 Higher Essential Skills Paper 1. Let's get started. Right, so question 1. We have a triangle with these vertices and we want to find the equation of the median through T. So, the median is this line here and it passes through the midpoint of the opposite side, UV. So we've got to find the midpoint of UV and we do that like this. We just say average the x coordinates and average the y coordinates. So we get 4 plus 6 over 2, 1 plus 7 gives you 5, 4. So we've now got the midpoint. The midpoint is 5, 4. Now we've got 2 points. We've got another point, so we can work out the gradient Tm. So the gradient of Tm is going to be 4 take away 3, that's the difference in the y's, and 5 take away negative 2, the difference in the x's. Work that out, you get 1/7. The next step is to use this formula here, y minus b equals mx minus a. We've got m, there it is, a and b. Now I'm going to use 5 and 4 because it's easier than using a negative value from this point. So let's put them in. We get y take away 4 is 1/7 bracket x take away 5. Multiply everything by 7 and then take away the bracket then, so we get this. And then we want to write down x take away 7y plus 23 equals 0. So all I've done is I've taken all of this to that side. So we have x already, plus take away 7y, plus 28, take away 5 gives you plus 23. 3 marks for that question. Next question. A function is defined by this formula. We want to find the inverse function. So first of all we call this y, and then we just swap the two sides around like this. We want to find x on its own, so multiply everything by 2. Let's move the minus 5 to the other side, it becomes plus 5. Now divide everything by 4 to get x on its own. And then all we do next is we swap x and y. So y becomes 2x plus 5, but y is going to be this value here. So we finish it off by saying f minus 1x equals 2x plus 5 all over 4. That's worth 3 marks. Next question. We're given this function and want to find the derivative when x is minus 1. So we just differentiate f, which means you bring 3 to the front, the bracket stays the same, and you reduce the power by 1, and then you multiply by the derivative of the bracket, which is just 4, because the derivative of 4x is 4. Tidy this up, you get 12 times this bracket squared, and then you want to find f dash minus 1, so you just put x equal to minus 1 here. So this becomes 4 times minus 1 is minus 4, plus 1, and then this bracket is minus 3, all squared is 9, so it's going to be 12 times 9. The answer is 108, and that's worth 3 marks. Next question. A log question. Evaluate this log expression. Now the first thing you've got to know is that when you've got a number in front of a log, you can bring that number in and it becomes a power, like this. Now we've got it 3 times, so this is a third, you bring it in, becomes power a third. There's a 7, you bring it in, it becomes power 7. There is a half, you bring it in, it becomes power a half. Now this is the cube root of 125. This is just 2 to the power 7. We can work it out, and that's the square root. So your answer is going to be this: log of 5, log of 128, and log of 10. That's the cube root. That's 2 to the power 7, 128, and then that's just 10, the square root of 100. Now we've got to use 2 laws next. When you add logs, you can just find one log and multiply the 2 numbers that you're taking the log of. But then we've got take away a log 10. When you take away, it becomes divide. So what we get is the log, a single log of the first 2 numbers multiplied together, and then the second one goes down because we've got a take away there. Now this is a half, 5 over 10, and you multiply it by 28, so you get log to the base 8 of 64. How do you evaluate this without a calculator? Well, you say to yourself, what is the power to which 8 can be raised to give you 64? And the answer is 2. So there is the answer, worth 4 marks. Next question. We have a line that makes an angle of pi over 6 radians, that's 30 degrees with the x-axis, and it passes through that point. You can see it's a negative gradient line. It's going downhill. We want the equation of the line. Now the first you've got to know, if you're given an angle here, is you've got to know that the gradient is equal to tan theta, where theta is the angle that the line makes with the positive direction of the x-axis. Now that's not the angle we want, it's this angle here. Now to find that, we've got a straight line, so to find theta, it's going to be pi, which is 180, take away pi by 6, so which is 30, which is 5 pi by 6. So the gradient is going to be tan of 5 pi by 6, that's tan 150. Well, let's get the cast diagram. Where is 150? Second quadrant. Only the sign is positive, so this is a negative number, which is what you expect because this is going downhill. So it's going to be negative tan of pi by 6. Now, pi by 6 is 30 degrees, so let's draw the special triangle. There's pi by 6, 30 degrees, and you put the numbers in like this. Try to remember that, you have to remember it. And now we want to find the tan of this angle here, so it's 1 over root 3. The negative sign will have to be there as well, so negative 1 over root 3. Now we've got the point, either at 4, 0, and we've got the gradient, so we can find the equation of a tangent. So the equation of the line is given by this formula. Put 4, 0 into the appropriate place there, and m as this number, and we get that. Now just multiply everything by root 3. You get root 3y, because obviously that's just going to be y on its own. And then I've taken the minus sign through the bracket, so I get minus x plus 4. Let's just rearrange it slightly and go x plus 3 root y equals 4. All I've done is take the negative x over, and that's worth 3 marks. Next question, we want to find the equation of the tangent of the curve at the point when x is 2. First step is to rewrite y with a power, not a fraction. 8 over x is 8x to the minus 1. Now we can now differentiate, because we want the gradient of a tangent is dy by dx. Differentiate this. So it's going to be 2 times x squared becomes x, that's 1 less, and then minus 1 times 8, x to minus 1 becomes 1 less power, so it's x minus 2. And then we just change it around into the same form. 2 times 2x is 4x, and then this part you bring x minus 2 down and you get a fraction. Now we know that x is 2, so we can work out when x is 2, this tangent will be, put it there, 4 times 2, 8 over 2 squared. Work this out, it's quite easy, it becomes 6. Now we've got x is 2, we need a point, so we've only got one coordinate, so we need a y coordinate, so we have to do x is 2, go back here and find what y is. So it's going to be 2 times 2 squared plus 8 over 2. Work that out, it's not too difficult to do. 4, 8, 8 and 4 is 12. Now the equation of a tangent is given by this. We've got the point 2, 12, and we've got the gradient. Let's put them into here. So it's y minus 12 equals 6x minus 2. And then all I want to do now is multiply the bracket out and then rearrange it. So we get y equals 6x. Well, we didn't have to rearrange it because minus 12 is the same as minus 12. They'll cancel out, so y equals minus 6 is the answer. 5 marks for that question. Next one. We've got a straight line that cuts a circle at 2 points, P and Q. We want to find what are the coordinates. So what we have is we've got an equation and we've got another equation. We want to find out where they cross, so we just solve them simultaneously. So we put, the easiest way is to put this x into, every time you see x here, change it into 3y plus 5. Substitute x into this equation. So we get this. So x squared becomes this bracket squared, 10x becomes this, and everything else stays the same up here. When you square 3y plus 5, you get 9y squared, that's square the first one. You multiply the 2 in the bracket, that's 15, you double it, that's 30y, and then plus 5 squared is 25. This 10 times the bracket gives you 30y plus 50, and then we just tidy it up from here. So we've got 9y squared plus y squared, that's 10y squared. I've got 25 and 50, take away 75, so the numbers cancel out. 30 and 30 is 60, take away that, 10 is 50. So we get this expression, that equals 0. We want to find what y is, so let's factorise this. So it's going to be 10y coming out, y plus 5 left. Now, easy to solve that. This can be 0 or that can be 0. So y could be 0 or y is -5. Now we want to find the coordinates. So let's just look at this. It looks like y is negative, so that's probably going to be this one here. So the x-coordinate of P, just go back to here and you put y equal to -5. So that's what I've done there. Let's work that out. 3 times -5 is -15, plus 5 is -10. So the next one is Q. The x-coordinate for Q is going to be putting in the 0, because obviously the y-coordinate here is 0. Put it into there as 0, so that's going to be xq equals 5. We've now got the 2 points. P is -10, -5, and Q is 5, 0. Okay, next question. We've got to show that this x plus 1 is a factor of this expression. And then for part 2, we've got to factorise it fully. So let's just do that with a synthetic division. So there's a synthetic division table. The top line comes from the coefficients of the expression, 2, -9, -6, 5. Don't put 1 there, you put the root there, so it's going to be -1, put -1, so that comes down, multiply by that becomes -2, add that becomes -11, multiply by -1 gives you 11, add gives 5, multiply gives -5, when you add you get 0, and that's the remainder. The remainder is 0, so you must say this, remainder is 0, therefore x plus 1 is a factor. Now how do we get the other factor? This is what we do. For part B, we want the other factor, or factorise it fully. We say x plus 1, so that's the first factor, and we get the second one from this part here. 2x squared, take away 11x plus 5. Now this is easy to factorise, so you're going to go x plus 1, 2x minus 1, x minus 5. How do I know? Well, it has to be a negative there, because 2 negatives multiplied to give a positive, and the only thing could be 1 and 5, and that gives you this expression here. That's worth 4 marks in total. Now this question is a cubic. What you have to do is sketch the graph of this. Now, this is a bit tricky because it's transformation of graphs. There's 3 things happening to this f function. We're going to do this to it, which is we're going to multiply the x by 2, then we're going to make it negative, and then we're going to add 3. So let's look at this then. So the first thing you've got to do is you've got to say that's what happens when you do the first one. When you double the x, you squeeze in the graph, so that the x-coordinate goes to -2, 5, -4, 5, that turning point up here is squashed, it's halved because you do the opposite of 2x, you squeeze it along there, so it becomes -2, 5. Now this one doesn't change because obviously x is 0, and if you multiply it by 2 you still get f of 0, which is the same number there. Now the next one you do is you've got a negative sign. When you take this function here and you do a negative on it, you just flip it, you reflect it in the x-axis. So we have, that's what you get. So you've reflected it in the x-axis. So what's happened to the points then? This point, which was, it's going to become -2, doesn't change. When you reflect in the x-axis, the y-axis, the y-coordinate changes from positive to negative, or in this case, from negative to positive. And then we're going to add 3. That means the y-coordinate is going to be pushed up by 3. So each of these two points, the y-coordinate is going to change by 3 up. You have to add 3 to each of these. So you're going to get, it goes up, and then you say -2 doesn't change, 0 doesn't change, but -5 has got to add 3 to give -2, and 2 adds 3 to give 5. Now you've got to indicate them on your final diagram. So I would put this point down there and that point up there, make it clear for them. Now on a separate diagram, sketch a possible graph of this derivative. So let's go and do this on a different diagram. The first thing you've got to know is what's happening. Well, we know that there's the new diagram. This is not it's not y and x anymore, it's y dash, that's the derivative, and that's x. So you just bring this down, this turning point, the two turning points, you just bring them down and you put them in there. They'll become zeros because the gradient is 0, so that has to be a 0 down there. And this one will become 0 as well. So we've got another 0 on this. So we know that we had a cubic function. When you differentiate a cubic, you're going to have a quadratic function. So this has got to be a quadratic. Now, is it going to go like this, or is it going to go like this? Depends on what you've got to look at. So let's see what we'll do. On the left of the turning point, you've got a positive gradient. Then you come down a negative gradient until you touch this turning point here. That's 0, a 0 gradient, and then you have a positive gradient. Now, in each of these ones, we can say, what's happening here? What's happening in this? It's positive. What's happening in here? It's negative. What's happening in here? It's back to positive. So we have a point here, a point here, a point here. It's got to pass through these two blue points. So the graph's going to look like this, something like this. So you've got to draw something like that, making sure that you've got -4, 0 and 0, 0 there, and that's worth 3 marks. Next question. We have 3 points collinear, and these are the coordinates in 3 dimensions. We want to find the coordinates of C given this information that B divides AC in the ratio 3:1. So first of all, I'm going to draw a straight line because that's what it says. They're collinear. Now we know that B divides AC in the ratio 3:1, so I'm going to put B there closer. I'm going to put 3 and 1 because that's 3 parts and that's 1 part. Now how do we do this? We want to find the coordinates of C. The first thing I'm going to say is B to C is 1/3 of A to B, because 1 is 1/3 of 3. So all you do now is you change that into BC is the same as C take away B. That's a position vector from the origin, take away B. 1/3 of AB is B minus A. Now all I do next is I just multiply this out. I'll take the B over and then I can put these in. We know what B is and A is, so we can just put them in like this. So it's 1/3 of the column vector B take away column vector A plus 713 because that's the coordinates of B. Now we have to tidy up this middle bit here. 7 take away -2 is 9, 1 take away 7 is -6, and 3 take away -3 is 6. So we're going to get 1/3 of 9, -6, 6, but we've got to add on B at the end there. We've got to find 1/3 of this and then add on this. So let's see, 1/3 of 9 is 3 plus 7 is 10. 1/3 of -6 is -2 plus 1 is -1. And 1/3 of 6 is 2 plus 3 is 5. So we've now got the position vector for C. So we can then say that C is just 10, -15. 4 marks for that question. Question 11, worth 2 marks. Find the integral of 8 sine bracket 2x take away pi by 6 dx. Okay, we've got to integrate this, so what we do is we say the integral will be, the 8 is a constant, so you leave that where it is. Sine changes to negative cosine of what you have, which is the bracket, and then you divide by the derivative of the bracket, which is the derivative of 2x is 2. Now we just need to tidy this up. Half of 8 is 4, with a negative sign is -4 cosine 2x minus pi by 6 plus c. And that's 2 marks. Okay, question 12. Part A. Solve the equation sine 2x take away 3 cosine x equals 0 for x between 0 and 2 pi radians. Okay, there's the equation. The first thing we do is we change sine 2x into 2 sine x cosine x, and then we've got a common factor of cosine x. So the next step is to take out cosine x as a common factor to give this. We've got two things equal to 0, so cosine x could be 0, or 2 sine x minus 3 could be 0. That doesn't change, but we can change this into sine x on its own, so we get sine x is equal to 3 over 2. Take the -3 over and divide by 2, and that's what you get. Now we're going to use this in a minute, but let's look at this. This is saying sine x is 3 over 2. That's not possible. 3 over 2 is 3 halves, 1 and a half, and the sine cannot exceed 1. So there's no solution for that. Here we're looking to see when is cosine 0. Well, this is the 0 there for the y. So it's going to happen here and here. That's 90 and 270. When we equate that to radians, we get the answer x equals pi by 2 or 3 pi by 2 radians. Okay, next question. Now the next question is we've got to solve this equation. Now there's the equation we want to solve. We've just solved this one. Now they're almost the same. If you look at it, you'll see that this one we know had solutions pi by 2 and 3 pi by 2, but the equation that we have here is the same as before, with x being replaced by 2x. So this x, change it into 2x becomes 4x, change this x into 2x becomes 2x. So we know that the solutions are going to be the same, but not x equals pi by 2, it will be 2x equals pi by 2, and then there's two more solutions if we add 2 pi to each value. So if we add 2 pi to pi by 2, we're going to get 2.5 pi, which is that. If we add 2 pi to 3 pi by 2, we're going to get 3.5 pi, which is 7 pi by 2. Now we don't want to get 2x, we want to get x. We divide all of that by 2, and you get x is 1/4 pi, 3/4 pi, 5/4 pi, and 7/4 pi. And that's a total of 5 marks for question 12. We come to the last question, question 13. The diagram shows two right-angled triangles that have a common side, and the angles shown are beta up here and theta down there. We want to find out sine beta. Well, we can't do it until we find this one here. So to do that one, we've got to square 7, square 3, subtract them, and then get the answer. Take the square root. Root 40. That's 49 when you square it. Take away 9 when you square it. That's 40, and then take the square root. Now we need to get this one also. So let's see what we've got. Two short sides, we want the hypotenuse, so square, square, and add, and then take the square root. That'll give you root 44. So we want to get sine of beta, so it's going to be, there's the angle opposite over hypotenuse, root 40 over 7, and we want sine theta, which is, from this one, it's opposite over hypotenuse, root 40 over root 44. Now the second part of the question says we want to show the exact value of this is equal to this fraction. So we have to expand this out. Sine bracket beta plus theta is sine beta cosine theta plus cosine beta sine theta. Now we have to be careful when we plug the exact values in. We've got two of them here. We can put the other ones in from the triangles that we see here, and we get that. So we now have got to simplify all of the top and all of the bottom. So we're going to have 2 root 40 plus 3 root 40. That's 5 root 40. This denominator is the same, 7 root 44, 7 root 44. So it's going to be 5 root 40 over 7 root 44. Now we need to change these roots into simpler form. 4 divides 40, and so does 4 divide 44. So we just do it this way. We say 4 times 10 is 40, but we make it root 4 root 10. 4 times 11 makes 44. That's root 4 root 11. Now the root 4s will cancel to leave this 5 root 10 over 7 root 11. But here we want to get to a rational denominator, so we multiply this fraction by root 11 over root 11, which doesn't really change it because this is 1. And then we multiply the top. 5 times root 10 times root 11 is root 110. 11 times root 11 times root 11 is 11. Times 7 is 77. So that is the final answer. That was worth 7 marks, and that's the end of the paper.